Assalamu alaikum. This example illustrates how to solve a series parallel circuit. Find all voltages and current of each resistors in the circuit. This is the circuit. It has 7 nodes. As you see, series, again series. These two are parallel. After that, I will see, or more will clear to us to simplify the circuit. We have these two, R equivalent 1 and R equivalent 2. R equivalent 1 is 2 series resistor. So since this is R equivalent 1, the current, the equivalent current will be the same as IR1 and IR3. Same thing true for R equivalent 2. R equivalent 2 is R7 and R6, and the IR equivalent to equals IR7, which is equal to R6, because R equivalent 2 is obtained from 2 series resistor, so the series laws is correct here. Current is constant in the equivalent resistance, the one we replace, and in the 2 resistors. R equivalent 3 is 2 parallel resistors, so R4 parallel with R5, and the current, the voltage also will be the same, since this is a parallel resistor, R4 and R5, and VR equivalent 3, all are the same. After we redraw the circuit using R equivalent 1, 2, and 3, it is clear R1, R equivalent 1, and R equivalent 2 are parallel. So the current IR equivalent, the voltage, since they are parallel, the voltage VR equivalent 2, VR equivalent 1 equals to VR equivalent 4. And then after that, the circuit becomes a series circuit, and R total equals R1 plus R equivalent 4, R equivalent 3, and R8. Add them up, becomes 8 kilo ohm. And since R total obtained from addition of 4 resistors, then the current is fixed because they are in series. So I total equals 20 milliamp. Now to find the voltage and current, you have to go back into the original circuit step by step. Starting from this, now I know I total, and also I know from I total, previously I agreed that IR1, R equivalent 4, R equivalent 3, IR8, all of them has the same current. R1, R8, R equivalent 4, R equivalent 3, all of them has the same current. So this current is 8 milliamp, 20 milliamp, 20 milliamp, 20 milliamp, 20 milliamp. The voltage, you have to use Ohm's law. VR1 equals IR1 times R1. VR8 equals IR8 times R8. Here we obtained voltage and current for 8 and 1. Still we have 6 resistors to find their voltage and current. I will go back one step. R equivalent 4, which is equal to R equivalent 1, R equivalent 2 in parallel. So the voltage is the same, and VR equivalent 1 is the same as VR equivalent 2, is the same as R equivalent 4. If you divide IR equivalent, to find IR equivalent, you have to divide VR equivalent over R equivalent. It becomes very straightforward. Third part in the circuit, we looked at R equivalent 1 and R equivalent 2. Since R equivalent 1 and R equivalent 2 comes from addition, so the current, or it is a series part, so the current is the same. R equivalent 2, and we have R equivalent, IR equivalent 1, and we have IR equivalent 2. I think I made a mistake here. No, I didn't make a mistake. It will be clear later. IR7, R equivalent 2, IR equivalent 2, and here V and V4, the voltage. And then finally I will calculate R5 and R4, which are obtained from parallel combination R4 and R5, and that is R equivalent 3. VR equivalent 3 is calculated previously, and I can use that one to adapt it and use it here. This way I got all voltage and current. Thank you.